everyone, and thank you for coming to the talk today. So I'm going to talk about serverless and a function as a service. So what is serverless? What is a function as a service? So before we get into it, I'll just talk a little bit about myself. So as Jan pointed out earlier, I have some previous experience working in help desk before moving to Japan. And this is kind of around when I think my interest in technology really started to shine. And then in 2016, I moved to Japan and knew I always kind of wanted to continue working with technology, but just never really got around to doing it until I decided to join Code Chrysalis. And then I love coffee. Probably have a cup or two every day. Coffee keeps me going, especially in the mornings. And I think challenging myself is important. So one thing we learn here at Code Chrysalis is that, to get comfortable being uncomfortable. And I think this says a lot with challenging yourself, step outside of your boundaries, push yourself outside of your comfort zone. And you can really start to see growth there. For example, this tech talk, this is definitely a good way to challenge myself or challenge yourself. So let's go ahead and get right into it. So introduction to serverless. So I'm going to kind of go over what are servers in general, just to give you an idea of what are servers, maybe how do they work. And then section 2, I will introduce serverless, talk about it, go over, what is it? How does serverless work? And then section 3, we're going to talk about function as a service, which if you think about it, it's kind of like a subset service of serverless. We'll talk a little more about that later. And then section 4, go over benefits and drawbacks of serverless. So maybe if you're thinking about using serverless, you can kind of weigh the options if it's good for your scenario. And then section 5, we'll go over kind of the future of serverless. So these are just some, ideas of where serverless could be going. Obviously, we don't really know, but we can, think about it, which is quite exciting. So first, what are servers? So servers, we can have physical servers and virtual machines. So a physical server is exactly that. It's like a giant, it's hardware that is built specifically for being a server, doing server things like holding data, hosting websites, things like that. And then virtual machines is more of the software side. So it's software that can run like a server. But the cool thing about this, you could have this software running on your laptop at home, your desktop at home, or maybe your computer at work. So it's just running on top of a regular machine instead of a machine that's specifically made for being a server. And then servers, they store data from websites that they are hosting. This is one of the most common uses for them, just storing all this data. So for example, when you go to Facebook or something, your friends list, your posts, that all has to be stored somewhere. So, that's kind of where servers come in. And then servers also share data with other computers and mobile devices. So the server is not the machine that's interacting with the person, it's interacting with other machines like your phone, your tablets, your computer, and then those machines are the ones that are interacting with you, the human element. All right, so kind of, what are servers again? So, we have things like mail servers. I'm sure, when you check your email, you have your inbox of 1,000 emails like me. And obviously those are being stored somewhere and they're being stored in a server and being run by the server. And then we have things like your phone, which can connect to a server. So again, when you're visiting your favorite social media site like Reddit or Facebook, all that information has to come from somewhere, right? And it's coming from a server. And then maybe you're really into gaming. So if you're playing online games, there are servers that host those online games, or if you have games that save your data on a server instead of saving it locally, servers are used for that as well. So let's kind of imagine. So you're at your computer and you're going to facebook.com. So, after typing the URL, pressing enter, initial communication is made with something called a DNS server. And what this server does is take that facebook.com translate that URL to something called an IP address or internet protocol. And this is kind of a translation. You think of it like your home address. So this IP address is going to a home location or the location server, the home server. And it's easier for the server to read compared to the facebook.com, which is more just like a human element. So it's easy for us to read instead of the numbers. So when it finds that location server, the server itself will bundle up all that information, the content of that you requested or the content of their websites, advertisements, we all like advertisements, but, it bundles that as well. And then it'll send that back through the internet and to your device where, when you access facebook.com, your homepage, all that information is coming from a server. So it's, really interesting to think about. Very like kind of a simplistic way of how servers work. So now we're going to talk about traditional servers. So traditionally, companies have physical servers on site. And they usually have to deal with continuous maintenance and IT assistance. So when these servers are physically on site of the company, they have to either have a dedicated IT team, or maybe they outsource a third-party team to take care of these servers, but it can cost, a lot of money. And then it can also create a lot of, and then for developers specifically, they have to pay attention a lot to the server itself, the infrastructure. They have to concern themselves with these areas of how they're going to develop and everything, instead of really focusing on what they want to do is, programming, unless they really like server infrastructure as well. But it can, take a lot of time to get through that. So now let's imagine you are a developer. So you want to start a new project, but first you have to plan. With this new project, maybe you're using new hardware or new server infrastructure. So what kind of hardware do you need? Maybe it's a new server, so you have to think about how much power do you need? For example, how much, processing power, how much storage? Do we get enough storage for just now, or do we plan for the future? How much memory are these projects going to take? Should we get just, the allotted amount, or should we get more than we need? There's a lot of things they have to factor in. And then software. So with the software, which operating system? Do I want to go with Linux? Are we going to go with Windows Server? And then our environment software. What software do we need to work with our specific company needs? Updates. Windows is notorious for this, especially if it's, in new infrastructure. If it's a earlier version of, like, say, Windows Server or something, you're going to have to go through updates with not just the operating system, but all the software that you're installing after that. And then network. How are we going to configure the network? So a lot of things to worry about. And then maintenance, again, updates, if there are major updates, hardware replacements, if, say, a server breaks down, you have to decide what hardware do we need to replace, how much is it going to cost, how long until we receive it. So there's a lot of worry there for, the client side, the developers. So this is kind of where serverless comes in. So introducing serverless. So serverless allows the use of servers without physically being present on site. So serverless does not mean that the server is just gone, it's non-existent. You're still using a server, it's just not physically located near your, developing area. It could be monopolized by a developer providers who have these servers located in, different areas. And then also serverless offloads responsibility for common infrastructure and the management tasks. So for example, again, what kind of hardware do we need? How are we going to scale these servers? How are we going to maintain them? A lot of this is taken off of the developers and taken off of the company, and it's all done by the provider. And then one of the coolest things is companies pay for what they use. So traditionally, servers, they run 24 hours, 7 days a week. They need to do this in order to, in order for people to access the data, in order for the servers to continue running the software. While in this case, you're only paying for the software that you are using at the time or the resources you're using at the time. And then again, developers focus less on the server and more on the task, which is developing, which they love. So serverless is definitely becoming popular, especially these past couple of years. You might be seeing a lot of articles online saying things like, why now is the time to go serverless? Is serverless taking over? The serverless revolution is happening. So there's definitely a lot of talk about serverless in general. So kind of go a little more about what are servers. So, and I'm sure a lot of people have heard about cloud storage, and maybe a lot of people are using forms of cloud storage on their phones, on their tablets, on their computers. Things like Microsoft OneDrive, Apple iCloud, Google Drive, these are kind of small versions of cloud storage that, that back up your photos, maybe your contacts, maybe, your favorite pictures, things like that. So you could kind of think of the serverless as like a much bigger version of this. And it does a lot more though too than just, simple storaging. So let's take a look at serverless. So it is a cloud-based execution model. So meaning that code written by developers can be sent to the cloud environment to be ran for applications with a service such as AWS Lambda, which I'll talk a little bit more about later. And no physical servers or virtual machines on site. So they are deployed automatically in the cloud by vendors, which I'll mention. And cloud providers take care of provisioning server environment. So they take care of the maintaining, the scaling of the servers, the architecture. And so serverless aims to make things stress-free. So for companies and developers making applications, by removing the server from the equation, it's a lot less concern for them, which is great. And serverless also quickly scales to events or requests. So for example, depending on the amount of traffic maybe your website gets, resources will scale up or down. And resources are things like, the memory, the storage, the CPU power. These can scale. So maybe you're still wondering, serverless, cloud storage, what does this look like? Is it just a cloud? So visualizing serverless. So essentially you could think as serverless as, clouds, as these things called server farms. So just big factories, big warehouses that contain a whole bunch of servers that are maintained by maybe some IT staff or by your chosen provider for your serverless. So they take care of all of that and just, kind of like a big infrastructure like this. So it's really interesting to see. So now let's kind of talk about how does serverless work? So cloud providers allocate machine resources on demand. So in other words, the vendors are only charging for actual usage or events that you use each month. They take care of the servers on behalf of their customers. So, vendors do all the maintenance, the configuration, and so on. And the computing is done in short bursts with results continuing to storage. So functions, which are like, you think like bundles of code, which are uploaded by developers and sent to storage or sent to the server to run the code. So imagine you are using serverless in this case. So maybe you're a developer. So you're sending out a request, or maybe you're sending this bundle of code through the internet to your provider. Your provider would be Amazon Web Services. And then you're using a service, which a service is a subset of serverless providers. So like AWS Lambda, and then it would run or execute on the servers. And, and the cool thing, like these servers could be located, in different regions. Like, they're not on site. They could be very far away, or maybe, they're in the next city over. So I talked a little bit about AWS Lambda, and this is related to function as a service, which is, again, a subset of serverless. So like almost think of it like a feature. So function as a service is a serverless computing that takes away the stress, kind of like, mentioned earlier. It provides a platform for customers to develop, run, and manage their applications. And then management is put on the cloud servers itself. The server must calculate parameters such as storage and memory on its own. So this is all done, provider side, server side. So the clients don't really have to worry about this so much. And another thing with function as a service. So imagine, you are sending a request, to your Amazon Web Services. So, pretend you're a developer and you're sending that request, that bundle of code, that function, and it's running to the server. And then the server is going to calculate the percentage of usage or the percentage of resources that it needs to take out in order to run these functions. So for example, 40%. And then, this is for this one run. And then at the end of the month, the amount of percentage that is used is calculated. And then it is billed back to the client. So you're just paying for what you've used, which is really awesome. So let's kind of think of another use case with serverless. So imagine, you have your website and and let's say this week, you see a lot of traffic. So you're going to need more resources. So using serverless, it can automatically scale, depending on that traffic. So it can scale up for this week since you have a large amount of traffic. But then what happens if next week your traffic goes down on your website? Well, serverless can, scale down, and then it will calculate the total accordingly, which is really interesting. So now let's talk about like some function as a service providers. So I did mention Amazon Web Services. And so we have AWS Lambda, which is, a service of AWS. And then we have things like Google Cloud Functions, which is a service of Google Cloud. And we have Azure Functions, which would be like a service of Microsoft Azure. So, to give you a better idea of what these, things are, what function as a service is, and these services, you think of function as a service, again, as a subset of serverless. So features of your provider. So talking about that, we're going to talk a little bit about AWS Lambda, which is again is a service of AWS. So AWS Lambda is a serverless computing platform. It is event driven, so developers don't have to worry about which AWS resources to run or how they will be managed. Code can just be put on Lambda and it will run. And then code executes based on response of events. So events happening in AWS services, such as, adding, deleting, updating data, files, or any sort of requests. And then it also helps with focus on the core product and the business logic. So this means that developers don't have to worry about managing, operating systems, access and control, OS patching or operating system patching, sizing, provisioning, scaling, all these, extra features or extra things that they normally would have to worry about. So again, let's, go back. Let's imagine you are a developer. So you upload your AWS Lambda code. It can be in any language, supported by AWS Lambda, say, for example, C#, JavaScript, Python. You can use other AWS services to activate Lambda. So services such as, AWS S3, Amazon API Gateway, or DynamoDB, which is like a database service. And your code is uploaded along with event details. So AWS Lambda will help you as it is triggered with these events. And then AWS Services activates AWS Lambda. So which in turn executes AWS Lambda code. And you are charged for the use. So AWS only charges, for the AWS Lambda code that is executed. Otherwise, you could be charged nothing. So let's imagine, you get your bill at the end of the month. This is potentially what it could look like. So we have the number of executions, so the amount of code that was ran, memory allocation, so the memory that was needed, and then estimate average duration. So how long did it take for your code to run or execute? And then, you have your total bill at the bottom. So, obviously this could be either cheap depending on, how much you're executing code or running code, or this could be really expensive if you have a lot more activity going on. So let's kind of talk about benefits of serverless. So serverless, deploying serverless is not very difficult. If an application needs to be created quickly, it does not take weeks or months to deploy, focuses on code and releases immediately. Scalability is automatic, and you don't have to worry about provision needs or the resources. Then costs can be quite low. Again, serverless takes less computing power and the human resources. So no, you don't need your IT department to deal with this. You don't need to worry about how much power are we using each month. It's, it can be very beneficial. And better scalability. So it's easier to begin implementation of an app with serverless than with traditional methods, and improve flexibility. So, serverless provides benefits with not being bound by these constraints, which is really nice. So, you're thinking, oh, serverless sounds really cool, but there are some drawbacks too. So let's take a look at those. So a learning curve. So with a learning curve, there's a lot of documentation does exist, but a lot of the documentation can be very dry and can be difficult to understand. And there's a lot of it, so it can also be overwhelming and it could take time to learn. Cold starts. So cold starts is when a new request happens to a serverless function. And it's needed to load first into the memory of the server, and it needs to respond to the request, and then it can start sending. So if you're executing and running code for the first time, or an application for the first time, it's going to take a while initially for that first start. So we call that a cold start. And vendor lock-in. So, imagine you choose AWS for your provider, which is great and all, but then you're going to have to commit to probably a long period of time with them, because once you set up that environment, once you get, basically your development is around AWS, tools, if you ever want to switch to, like, say, Azure or Google, you're going to have to take into consideration just how much are you going to have to change of your environment, your infrastructure that you have now, if you want to move to something totally different. And then, developers have to learn new tools as well. And it can be hard to debug. So in the sense, so it's difficult to require the appropriate information for debugging. It can be troublesome to use the debugging tools provided by the vendor for developers, especially if they've never used them before. And also it can be difficult to gain access to minute details for root causes of the problem, because, you're using a provider at this point. So if there's a problem, if the problem is a root issue, then you have to go through your provider, you have to go through the hierarchy of who to talk to, you have to wait till they approve your request. And, this is going to take more than a couple minutes for sure. So what scenarios might serverless, be best for? Well, maybe mobile backends, chatbots, things like machine learning, the Internet of Things, modest streaming processes. So just some scenarios where serverless can be great. And this is exciting. You know, the future of serverless, where could it be going? So the advancing of technology and growing need of cloud solutions is definitely becoming more prevalent, especially after COVID. You know, we're seeing a lot more companies moving towards remote work and less people going to the office. Some companies might even, you know, no longer be renting out an office just to save money. So it makes sense to go serverless if you no longer need these servers on site. And with the amount of data in the world, serverless can be a great solution. With companies, you know, needing to have like outsource their own servers and stuff or use their own servers on site, they are kind of creating a lot of pollution with just, you know, hardware infrastructure that is possibly being scrapped away or, you know, that, you know, may not be being recycled. But if it's all provisioned and all controlled by like serverless providers, they could better control like, you know, reusing the hardware or recycling it more properly. And serverless can be great for developers, allowing them to focus more on the tasks that, you know, they're doing, to focus more on the developing, the programming. And serverless is still a fairly new technology, so it's really exciting to think about where could serverless be in the next 5 or 10 years, especially again, kind of going back to how companies are becoming more remote work like oriented. Serverless could really develop in the next 5 or 10 years with this kind of thought in mind. So I really hope you enjoyed this, and I hope you know, when you think about serverless, maybe you're considering about approaching it now that you have a, you know, a general idea of how it works and, you know, what it is. So without further ado, I'll just say thank you very much for listening. If you would like to contact me, here is my Twitter, my LinkedIn, my GitHub. And thank you very much for listening again. And Yan, I will pass it on to you.